Okay, we got 5 and 7 on the practice test. What do we do to 5? What's our first step? Greatest common factor. Always GCF. You know that 5-step method. GCF. You know, very star variable, right? Parentheses star variable, and just work on down the line. That first step is always GCF. So what goes into 9 and 81? 9. Okay, and it goes in there x and 9 times, right? And that's done. That's factored. Okay? So we move on to the bottom. We do the same thing. What goes into 55, 5, and 90? 5. Good. Okay? Is there anything else? The x's. Good. Squared. Good. Alright? So we pull out the 5x squared, and what do we leave? X squared minus 11x minus plus minus plus.
It's a plus better than 90.
Oops, my bad. It's supposed to be a plus, so this will be a plus. Okay, and then what?
30?
18? 18? Okay. Alright, 18. Sounds good. But 5 goes into 9 once. 5 goes into 40 8 times, so 18. Alright. Now, so that's the first step. GCF, right? And then second step is parentheses, star variable. Now there's no star, so there's no star cleanup. Okay? So we just do the other two, which is signs and product and sum. Okay? So, parentheses, variable, sign. This tells me that they are same or different? Same. So they both are minus. Okay? What's my product? 18. What's my sum? 11. So two things that multiply to be 18, but they add or subtract to be 11.
9 and 2.
Good, 9 and 2, and they add, right? So, 9 and 2, and it's important to put a big number first. I know it doesn't matter on this one, but on difference problems it really matters. So don't get caught up putting them in the wrong order, believe me. Big number first, it'll work out in the long run. Okay? So now we're going to rewrite these. I have x minus 9 times 9 over x minus 9 times x minus 2. Okay? And so now I need to go, okay, the bottom cannot be 0. Which means x minus 2 cannot be 0 and x minus 9 cannot be 0. At this point, you should be able to look at this and go 9 and 2. Okay? I mean, this should be like automatic at this point. Okay? You know you're going to add 2 to both sides. It's always going to be the opposite. Okay? What's the problem?
What happened to the 9 and the 5x squared? Are you supposed to keep those out?
Oh! Very good. I forgot this piece, didn't I? That's huge. That should be out here. Right? And I should know whenever I have a single piece that it should be a 0, right? That x can't be a 0. Okay? That's huge. Very good. Thank you. This should always be brought down right away, or otherwise you forget that you had it. And that's exactly what I did. I forgot that I had it because I didn't bring it down right away. Okay? Alright, so now we cancel out. Can we cancel 5 with the 9? No. Any x's? No. So we just got 9 over 5x squared times x minus 2, whereas x cannot equal 0, 2, and 9. Okay? Now it's more appropriate to put them in ascending order. Okay? I don't mind if you say such that, if you say x cannot be such that, or if you say whereas. It's really up to you. Alright, this is a different type of problem. This one is saying you've got negative exponents and now we want to put them in, make them all positive. Okay? So one thing we have to realize right away is that there's a line here, right? And these are going to come down. And so we'll rewrite these. 4x squared times 4, okay? And x times y. Now what that does is it just resets everything. It just resets it. Now the 4 doesn't come down with the x because the 4 is not part of that negative exponent. Okay? And so a lot of students get confused with that. They also get confused with what do I do with the 4s? Do I add them? No, it's multiplying. So 4 times 4 is 16. If I take 1 away from 2, what do I get left? 1, right? And that's it. That's it. Just one step at a time. Does that make sense?